All right, here we are back, and I'm looking at situations, and you'll be asked to determine before you work them out whether they are combinations or permutations. So again, the permutation formula, n factorial over n minus r factorial, where combinations are n factorial over n minus r factorial, and then the additional factor of r factorial. So when I describe the scenario, you have to decide if order counts, then you'll use a permutation, or if it doesn't. So let's look at this scenario and see which one it is. Suppose we have 5 cards. So we have a 5-card hand, and there are 52 cards total. I believe poker is like that. So say we have a poker hand. I want to know how many different hands are possible. Alright, so to think this through, whether it's a combination or a permutation, I just think of one hand. Suppose I have an ace of hearts, a king of hearts, queen of hearts, a jack of hearts, and a 10 of hearts. Would that be a good hand? I don't know much about poker. Alright, would that be counted differently than if I had a king of hearts, a queen of hearts, a jack of hearts, a 10 of hearts, and an ace of hearts? So this is a different order in this, but is not this the same exact hand as this one? So order doesn't matter with playing cards. So we are looking at a combination. We will be using this formula. So the combination of 52 cards, taking 5 at a time, is going to be 52 factorial divided by 52 minus 5 factorial times 5 factorial in the denominator, that is. So I see 52 minus 5 is going to be 47. So I can write out 52, 51, 50, 49, 48, and then stop at 47 factorial. So that's rewriting 52 factorial, stopping at 47, so that these cancel, and 5 is 5 times 4 times 3 times 2. And I can start taking this and reducing it. So 5 goes into itself once and into 50 10 times. 4 goes into itself once and into 48 12 times. There's other ways you can do this. 3 goes into itself once and into 12. It goes 4 times. 2 goes into 4 2 times. And there's other ways you might have seen to reduce. So I end up with 52 times 51 times 10 times 49 times 2. And when I multiply all that out, I get 2,598,960. So lots of possibilities for different card hands. All right, let's do another one. And let's say there are 10 girls and 15 boys that have tried out for the swim team. And we need a 12-person swim team. And we need 5 girls. And we need 7 boys. So, how many teams are possible with these parameters? 5 girls and 7 boys taken from 10 girls and 15 boys. Alright, in order to figure that one out, we have to know if we're looking at a combination or a permutation. So, if I have girl 1, girl 2, girl 3, girl 4, girl 5, and I have boy 1, 2, 3, 4, 5, 6, and 7. Does it really matter what order they're in? It does not. It's the same team no matter what order they're in. So once again, order doesn't matter, so we have a combination. So this time, however, I'm going to have to do this in pieces. So I have 10 girls total to pick from, and I can pick 5 of those. So I'm going to do a combination of 10 girls taking 5 at a time, and then I'm going to do the boys, a combination. There's 15 total, I can take 7 of those. So my math looks like this. 10 factorial over 5 factorial, 5 factorial. And here, 15 factorial, 7 from 15 is 8 factorial, 7 factorial. So when I worked this one out, it came out to 252 different ways. And here it worked out to 6,435. 6,435. So, what will I do with these two numbers, do you suppose? So this is all the different combinations possible for girls, and this is all the combinations possible for boys. And I want the combinations of them all together. What we're going to do is multiply those two numbers, and that will catch all the different combinations. And we have 1,621,620. All right, that is a good introduction to combinations, having learned permutations, and also a discussion of distinguishable permutations. So, distinguishable permutations and combinations is the best title for tonight's word. All right, carry on, class. Carry on.